Hello, Algebra. Today we are going to move on to exponents and exponents rules. The first term we're going to review is an exponent. An exponent is that little number at the top of the base, which is generally an integer that tells you how many times to multiply the base. So this number up top, that's going to be your exponent. And this down here, this is the base. So if I have 4 to the third power, that means it's 4 times 4 times 4. This exponent is going to tell me how many times to multiply the base. 4 times 4 times 4, 4 to the third power, is 64. 3 to the fourth power, that's 3 times 3 times 3 times 3, 4 times. And so that's going to be 81. That's different than 3 times 4, which is 12. 9 squared is 9 times 9, and that's also 81. It's going to be different than 9 times 2, which is 18. Remember, to square, the exponent tells me how many times to multiply the base. Now, here are a couple rules. For an exponent, any number to the 0 power is 1. So 10 to the 0 power is 1. 4 to the 0 power, it's 1. 256 to the 0 power, it's 1. 60 to the 0 power, it's 1. And 9,000 to the 0 power is also 1. Any number to the 1 power is itself. So 9 to the 1 power simply tells me there's only one of them. So there you have it. It's 9. 29 to the 1 power is 29. It's itself. And 98 to the 1 power is 98. Now, any number to the negative power or a negative exponent becomes a fraction. And then, if you can, you would solve. So I have 3 to the negative 2. This is a negative number. Because it's a negative, I know it's going to create a fraction. This is in the numerator. So to make this positive, it becomes the denominator. So 3 to the negative 2, to make that negative 2 positive, it would go to the denominator. And so 1 divided by 3 squared, 3 squared is a number, it's 9, it would be 1/9. Now, what if that exponent, which is negative, is down here in the denominator? I cannot solve it with the negative there. I need to move it then to the numerator so that this would become m to the fourth power, and it's over 1. It is not a reciprocal. This is simply saying I'm moving it from the denominator up to the numerator. So our answer is really just m over 4. If I have y to the negative 8, again, my exponent is negative, so it needs to go to the denominator. That's what makes it positive. And then I would make sure I have a 1 on the top. Any exponent or any number to a negative power becomes a fraction. If it's on the top, it goes to the bottom. If it's a numerator, it becomes the denominator. And if it's the denominator, it becomes the numerator. Now let's move on to multiplying with the same base. Okay. If the exponents have the same base, then they can be multiplied. And when I multiply them, I would add the exponents. So am times an, they have the same base, which is the a. I can then add the exponents, m and n. If a and b, am times bp, see how they do not have the same base? Because they do not have the same base, one is an a, one is a b, then nothing would change and it would just be the same, am times bp. Let's look at number 1 and see why it makes sense. We have y to the fourth power. That means I have y times y times y times y. Then it's being multiplied by y to the third power, y times y times y. So now everything is being multiplied, and there's 1, 2, 3, 4, 5, 6, 7 y's. Therefore, this is y to the seventh power. Now, if I added 4 plus 3 on the exponents, then that would also give me 7. Let's look at number 2. B to the negative 4 times b to the 5. Oh, remember this negative exponent? Where does it really go? Correct, in the denominator. So you would have b times b times b times b to the 4 down below. And this is a positive b to the 5, so it would stay in the numerator. This is b times b times b times b times b. Well, then these would cancel out, and you're left with b to the 1. Anything to the 1 power is itself. So it's just b. Coming on down, we have dividing integers. Now, if I multiplied and I added, then when I divide, I would subtract. Correct, they're opposite. Multiplication is the opposite of division, and so addition is the opposite of subtraction. If they have the same base and they're being divided, I subtract those exponents. So it's like having b times b times b divided by b times b. That's b squared down below. Well, these would cancel out, and again, I would have b to the 1, which at the end of the day is the same as b. Sometimes it doesn't look like they have the same base, because like I have 4 to the 7 divided by 7 minus 3 to the 4th. But remember your PEMDAS, parentheses would happen first. So then 4 to the 7th would be divided by 4 to the 4th, because 7 minus 3 is just 4. Now they have the same base. If they have the same base and you divide, you subtract the exponents. So this is 4 to the 7 minus 4. So it's 4 to the 3rd power. Well, 4 to the 3rd power is a number. It's 4 times 4 times 4, which is at the end of the day, 64. If you can keep going, you must keep going. Let's look at number 3. We have m to the 5th divided by m to the negative 3. But that negative 3 tells me that it should really be up top. So then I have m to the 5th times m to the 3, which at the end of the day, when I multiply, I add, is m to the 8. You could also say when I divide, I subtract. So this is now 5 minus negative 3, which is 5 plus 3. This is m to the 8 as well. Now, each of these by itself is a little bit easy maybe, but then what we'll have is something like that. Go ahead and pause and try, see how much you can do. All right, so you should have had 6 to the 0 power is 1. Anything to the 0 power is 1. 19 to the 1 power is 19. 12 to the 0 power is 1. This one's a little tricky. We have 4x to the 3rd divided by 2y to the negative 4. Keep in mind that this exponent is attached directly to that base. I see a positive exponent and I see a negative one, a negative 4. That means the y to the negative 4 needs to go to the numerator to get rid of that negative. So now you would have 4x to the 3, y to the positive 4 divided by 2. I move this entire thing up to the numerator. That's what makes it positive. Then, of course, back in the days, we had fractions that we would divide. 4 divided by 2. So that's just 2. And then I have x to the 3rd, and then I have y to the 4th. Number 2, you would have y to the negative 5th. Remember, it's a negative. Can't have that in a problem. To make it positive, it's simply draw your line, numerator, denominator. It goes down to the denominator. Now, again, I look at b, and b has a negative. It's a negative exponent. So if it's down on the denominator, it needs to move up to the numerator to make it positive. Technically, then, I have nothing left in the denominator. So then my answer is 2m squared. M6 times M4, that's M10, because when I multiply with the same base, I add those exponents. And then y third times y squared, I add those exponents, I get y to the fifth power. Then lastly, coming over, we have x4 divided by x squared. When I divide with the same base, I subtract, so my answer is just x squared. And then I have 2x squared times 7x4. This one's funky. I would multiply the numbers first because I still have to take care of numbers. And 2 times 7 is 14. But then I have x squared and I have x4, same base. Therefore, I'll add those exponents and I'll get x to the sixth power. All right, we're going to move on down to talking about integer exponents. So, we are now going to do a power to a power. A power to a power, we multiply. All right, so if you recall back in the days, you'd have like 2x plus 4. Well, whenever I had that, it meant to multiply, to distribute. And I would get 2x plus 8. This is similar just with your exponents. So we have am to the n. See that parentheses there? It's a power raised to another power. That means we're going to multiply. It's like a form of distribution. So if I have b to the 4 to the second power, again, I like to tell you what it means. It means it's b times b times b times b, but then it's happening 2 times. So then b times b times b times b, which means now there are 8 b's, b to the 8 powers. Well, what's 2 times 4? 8. There you go. We have 3 to the second power raised to the third power. So I multiply that parentheses. Visually, we should see it, power to a power. So now we have 3 to the sixth power. 3 to the sixth power is a number. It's 3 times 3 times 3, 3 times 3 times 3 times 3 times 3 times 3. Or you can put in your calculator 3 to the sixth power, and that is just 729. The next one I have is 10 to the second raised to the third power. So 3 times 2 is 6 again. That's 10 to the sixth power. So my answer is 1, 2, 3, 4, 5, 6. 10 to the sixth power. Now, if I'm doing that with just one, then power of a product is something very similar. If the exponent, again, is on the outside of the parentheses, it's power to a power, but now there are two things inside. I pretty much am distributed in its side. And remember, we're doing it to the power, so it stays up top. So in this case, 3 times 4, I'm multiplying the powers, the exponents. I get 3 to the 12th. And then 3 times 2 gives me c to the sixth power. Coming on number 2, we have 2 to the negative 3 power. So it's 2 to the negative 3. I distribute that. Everything inside the parentheses get the exponent. And it's b to the negative third power. But oh my goodness, these are negative exponents. So I'm not done. I have to put them in a denominator. So 2 to the third power and b to the third power. Remember, if it's in the numerator, I bring it to the denominator. That's what makes it positive. Then I see that I have 2 to the third power. That is an actual number. 2 to the third power is 8. So it's 8b to the third. Now we have power of a quotient. Similar process, right? All of these go together. So I would distribute that n. The power goes to both the numerator and the denominator. And I get an divided by bn. So if I do 3, that's the exponent to the 2. It's not 3 times 2, which is 6. It is 2 to the third power. And then I do the denominator divided by b to the third power. 2 to the third power is a number. It's 8. So then it's 8 divided by b to the third. Let's do another example. We have c to the negative 2 divided by m to the negative 3, all being raised to the fourth power. Again, you simply distribute it, and we get c to the negative 8 power, battery, divided by m to the negative 12 power. Then I'm going to realize, hopefully, that I have negatives. Oh no, there's negative in my exponent. Because there's negative there, I need to make them positive. So I am going to rearrange it. To make the c negative 8 positive, I have to bring it to the denominator. And to make m to the negative 12 positive, I got to bring it to the numerator. And so boom, there I get it. It's my final answer. Go ahead and do this one. Now that part jumped off, so we're going to make it a power of 3. So that I get y to the 6th divided by x to the negative 6. Keep in mind, this negative is down below. I have to make it positive. So my answer is y to the 6th, x to the 6th over 1, because I brought it up top. Now, considering those 3 rules, I want you to pause and I want you to try these practice problems down below. 1, 2, 3, 4, and 5. Down below in this bottom section. Pause and try. All right, now that you have paused and you're back, you would have had negative 2 times 4, which is x to the negative 8, and then negative 2 times 3, so it's y to the negative 6. They're both negatives, so you know you have to move it up or down. You would move the bottom one to the top, and you would move x to the negative 8 down below. On the next one, you would distribute. So we get m to the positive 12 over r to the negative 8. I have to move that so that it's m to the 12, r to the 8. On the next one, I would distribute, so I get 3 to the negative 4. However, that's a negative, so I have to put it in the denominator, 3 to the 4. And then 3 to the 4th power is a number. It is 81. So your final answer is 1 over 81. I have 9 squared there, and then 3 to the 2nd power as well, which is going to give me 81 over 9. I can still simplify that. And so my final answer is 9. Coming on down to the bottom, there's a lot going on. That's okay, one step at a time. You have to distribute to everything. So it's 3 to the negative 2, x to the negative 4, and y to the negative 8. Divided by, comes all the way down here, 4 to the negative 2. Everything gets that exponent. X to the 0 and m to the negative 6. Now let's clean some of these up because I see negatives up top, negatives down below. We are going to rewrite that. To make this positive, I would bring it down, so I have 3 squared. To make the x positive, I go x, and that's the 4. To make the y positive, I bring it on down. Now I'm on the bottom. 4 to the negative 2. To make it positive, I bring it up. X to the 0 power, well, anything to the 0 power is 1. So I need to fix that. And m to the negative 6, I would bring it to the numerator. I get m to the 6. Lastly, I'm going to evaluate this. So 4 squared is 16, and 3 squared is 9. Can anything go into both of those? No, so I'm good. And then anything times 1 is 1, so this is m6. And then we would have x squared, y8. Final answer. Ta-da! Now, the very last concept is the fractional exponents. If the base is raised to a fractional integer, it becomes the radical of the denominator raised by the numerator. That sounds weird. So if it's a to the b over n, it's equal to n, the square root of a, raised to the b power. Your base will always be here on the inside. Your denominator is on the outside, and it's going to be raised to the power of the numerator. You can see it both ways. Okay. So then we'll have 125 to the 2/3 power. You know it's going to be the root of 125. The denominator gets kicked on the outside, and it's raised to the power of the numerator. Again, you write your root. It's the root 27. Your denominator gets kicked to the outside. You can also see it raised to the power of the numerator on the inside. That's a possibility as well. 64 to the 1/6. I know it's the root of 64. The 6 is the root. And again, it could be raised to the power of the numerator on the outside. Technically, because it's a 1, you would probably just have the 6 root 64, because anything to the 1 power is itself. So you may not see that 1 out there. Let's look at the next one, 32. Again, you do your root 32. It is the denominator that gets kicked out to the root, and it's raised to the power of the numerator. If I have 25 to the 1/2, 25 is your base, and you'll have your square root. However, because there's a root here, and it's just the regular square root, you won't see this 2, because the fact that that is there tells me there are 2 numbers. The second root of 25 is the square root of 25. And lastly, for the 216, again, you put your base on the inside, your root is outside, and you could raise it to the power of the numerator, or the numerator can be in here. You'll see it written both ways. Now that we've done that, consider there is also an alternative. So if they give you the root and the square root of a raised to the b power, a is your actual base, and then it's your numerator over your denominator. So if I have third root of x to the 9, x is my base, and then it's the numerator, which is 9, over the denominator. Your denominator is always on the outskirts. Your denominator came out. Then you would have here y to the 12 divided by 4. That's your denominator. I was also supposed to tell you that this does simplify. 9 divided by 3 is really just 3. And then you would have y 12 to the 4th. Well, this is the same as also saying y to the 3. Let's come on down. So we have, x, the root is 4. So this is the same as saying x, the numerator, over the denominator 4. Y, the numerator, which is 12, over the denominator 4, which will simplify into x to the 1 power, which is just itself, and y to the 3rd power. 12 divided by 4 is 3. On our next one, we have the square root, but there's a number. This is really a root of 2, square root. The square root of 9 is 3. And then we have x, the numerator, which is 1, over the denominator, y, the numerator, which is 4, and of course, again, that is your denominator. So if I clean this up, I get 3, x to the 1/2, and y to the 2. Lastly, this one has a combination of everything going on. So 1, remember, if you have a parentheses, power to a power, you multiply. So we get x to the 16 and y to the 8 over 4, which is 2, but I want you to see it. And I'm multiplying that by the root y squared, so y to the 2 over 2. So my answer is x to the 16, no, not quite there yet, y to the 2 times y to the 1. Well, I'm multiplying with the same base, back there again, so 2 plus 1 is 3. My answer is x to the 16 and y to the 3rd. All right, and that is it. A lot of little rules. We will put them more together. And remember to do it, because in order to learn your mathematics, you must always and forever do the mathematics.